Okay, so I will share my screen. So yesterday we have seen the flip-flop using NOR gates. Today we will discuss about flip-flops using NAND gate. As we know, NOR gate and NAND gate, both NOR and NAND, both these are universal gates. Hence, if I can design a flip-flop using NOR gate, it also means that I can design a flip-flop using NAND gates. So I will just give you the diagram. This is the NAND gate. This is another NAND gate. As we know, for flip-flop, we require two NAND gates. This is the output Q. This is the output Q bar. This is one input. I will just say input 1. This is another input. I will call it as input 2. I am not calling it as R and S. Just I am calling it as input 1 and input 2. Second input of the NAND gate is the output of the other NAND gate. Second input of the second NAND gate is the output of the other NAND gate, first NAND gate. This is cross coupling. Correct. This figure and this figure, both the figures are same. Which figure? If I use this figure, this is input 1 and this is input 2 and this is the feedback. Okay. So what you can see, the output of this is first NAND gate, this is second NAND gate. Output of first NAND gate, let us say this, and this is second NAND gate. Output of the first NAND gate is connected as the input to the second NAND gate. The output is connected back to the input. Correct. Similarly, output of second NAND gate is connected to the input of the first NAND gate. The output of second NAND gate is connected as an input to the first NAND gate. Okay. Now I have not called it as input S and R, set and reset symbols. I have not used S and R symbols. Instead, I have used input 1 and input 2 because I don't know which input is S and which input is R. Okay. After I confirm that, then only I will tell that which input should be called as R input and which input should be called as the S input. Okay. Now let us say this is input 1, this is input 2, this is Q, and this is Q bar. Okay. Now let us say both the inputs are 0. Now we must know what is the truth table of a NAND gate. If the NAND gate has A, B input and Y output, means Y is equal to A dot B bar. So if A and B are 0, 0.0 is 0, bar of that is 1. 0, 1, 0.1 is 0, bar of that is 1. 1, 0, again 1. When both the inputs are 1, 1, 1.1 is 1, bar of that is 0. Correct. So, whenever both the inputs are 0 here, when both the inputs are 0, okay, this is also 0, this is also 0. As we can see, even if one input is 0, the output will be 1. Okay, so output of this is 1, output of this is 1. Okay, but Q and Q bar should be opposite to each other. If Q is 1, Q bar should be 0. If Q is 0, Q bar should be 1. But here what happens? Both the outputs are becoming 1. So this is an invalid state. So this state, I call it as invalid. This is the invalid state. Okay. If you remember, in case of NOR gates, flip-flop using NOR gates, when we apply the input 1, 1, both the inputs are 1, 1, then we were getting the invalid state. But in case of NAND gate flip-flop, we are getting the invalid state for 0, 0 input. This is the difference. Correct. Now apply 0, 1. Apply 0, 1. Okay, input 1 is 0 and input 2 is now 1. Is 1. Now this output is 1, last state. This output is 1. Now when for in NAND gate number 2, what we see? Both the inputs are 1, 1. So what will be the output? Output will be 0. In this case, the output will be 0. So if this output is 0 and this is also 0, what we get here? We get 1 here. For 0, 0, we get 1. Correct. So here the output is 1 and Q bar is 0. Now if I make input 1, 1 and input 2, 0, now what will happen? If I make input 1 as 1, input 1 as 1 and input 2 as 0, now what will happen? Now this is also 1. Correct. This is 1, 0. So input 1 is 1. Input 1 is 1. Input 2 is 0. So the earlier part was like this. Q was 1. Q was 1 and Q bar was 0. One zero one zero. Again, both the outputs will be 1. Sorry, when the input is 0, input 1 is 0, let us again I consider this. So here both the outputs are 1. Correct. If I make input 1 as 0 and input 2 as 1, now what will happen? If I make input 1 as 0 and input 2 as 1, now this output is also 1 and this output is also 1. 0, 1 will make it 1 and 1, 1 will make it 0. 1, 1 will make it 0. So this is 0. So 0, 0 will be 1. Okay, 0, 0 will be 1 and 1, 1 will be 0. So Q is 1 and Q bar is 0. Correct? Now I make input 1 as 1 and input 2 as 0. One zero one zero one one. Okay. As soon as I make this as 1 0, what will happen? This output will change to 1. This will become 1. When this becomes 1, 1 1, it will become 0 here. It will become 0. So this output will be 0. It will be 0 0 1. So Q will be 0 and Q bar will be 1. And last condition, if I make both the inputs as 1 1, input 1 is also 1 and input 2 is also 1. Is also 1. So what will happen? This is 1 1, this will become 0. This is 0 1, it will remain 1. It will remain in the same state. Last state. This will remain 0, this will remain 1. This is the last. So what do you see? For the input 0 0 condition, it is an invalid state for the NAND gates, flip-flop using NAND gates. Whereas when the inputs are 1 1, it is a last state for the NAND gates, flip-flop using NAND gates. This is completely opposite to that of the flip-flops using NOR gates. In case of NOR gates, when the inputs are 0 0, it is last state. And when the inputs are 1 1, it is invalid state. Whereas in case of NAND gates, when the input is 0 0, inputs are 0 0, it is invalid state. And when the inputs are 1 1, it is last state. So this is completely converse of the truth table of the NOR gates, flip-flops using NOR gates. Now here, one more point which I wanted to put was which input is R and which input is yes. Now, whenever the input is made 1 and if the output Q becomes 1 for that particular input, that will be called as yes input. Now here you can see in the second combination, whenever the input 2 is 1, the Q becomes 1 and Q bar becomes 0. It means that input 2 is a S input. And S means set. Whenever this input is 1, output will become 1. But the other input should be 0 in that. Now, on the other hand, if the input 1 is 1, then the output becomes 0. This is the reset condition. So I will say input 1 is called as R and input 2 is called as S. Okay, so this is the RS flip-flop using NAND gates. I think it is clear. So we have discussed three different types of flip-flops. One is RS flip-flop using NOR gates. RS flip-flop using NOR gates. Second one, RS flip-flop using NAND gate. And one more, D flip-flop using RS flip-flop, NOR gate. Similarly, you can also draw a D flip-flop using RS flip-flop NAND gates. Okay, I will just tell you how to draw that. Fourth one will be D flip-flop using again RS flip-flop, but using NAND gates instead of NOR gates. Using NAND gates. That I will discuss. Your NAND gate. Another NAND gate. There is a cross coupling of the inputs. Output of the first NAND gate is the input to the second NAND gate. This is R input, this is S input, this is Q output, and this is Q bar. Now here what I will do, I will connect one more NAND gate here. I will connect one more NAND gate. But it will be used as NOT gate. NOT gate using NAND gate. Okay, so this is actually a NOT gate. I will remove this R. And this S will be replaced by D. Okay, because here the data is only one. In RS flip-flop, we have two inputs, R and S. But in case of D flip-flop, we have only one input, that is D input. So instead of calling it as S, I will call it as D input. Okay. So as we know, if the D input is 1, means S is 1. S is equal to 1 means D is equal to 1. This is opposite. R will become 0. So Q will become 1. That. And Q bar will become 0. Now when the D input D is 0, means S is 0. So if S is 0, R will become 1. When R becomes 1, Q becomes 0. And Q bar becomes 1. Correct. So if I draw the truth table, D input, Q and Q bar, If D is 1, Q will be 1, Q bar will be 0. If D is 0, Q will be 0 and Q bar will be 1. So only two stable states, only two states will be there in case of D flip-flop. There will be no last state, there will be no invalid state in case of the D flip-flop. That is the advantage of D flip-flop. But the disadvantage is only one input is there, not two inputs. So control comes under only one input. Whereas in case of RS flip-flop, the inputs, two inputs control the outputs. That is the difference or comparison between the RS flip-flop and the D flip-flop. I think it is clear. Now, next part is clocked RS flip-flop. Clocked RS. Now, what is clocked RS flip-flop? Here, one more input has been inserted in the flip-flop. Okay, I forgot to give you the symbol of RS flip-flop. I will just simple RS flip-flop. I will just tell you what is the symbol of simple RS flip-flop. This is the block. This is the R and S inputs, and this is the Q and Q bar. This is RS flip-flop. Okay. What is the symbol for D flip-flop? In case of D flip-flop, we have only one input, that is D input. But we have two outputs, that is Q and Q bar. So this is nothing but the D flip. This is a symbol for the D flip. So whatever gate diagram we have drawn while discussing the RS flip-flop and D flip-flop, those gate diagrams, they are included in this square box. They are included in the square box. Now, when I say clocked RS flip-flop, there will be two inputs, no doubt, R and S, but one more input has been added, that is called as clock. Now, what is the how to draw the clocked RS? That is very simple. This is Q, this is Q bar. What I do, I add one more input to the NAND gate. This is the first NAND gate. This is the second NAND gate. The common clock input. This is R input. This is your S input. Okay. Now, sorry. We have to use the AND gate, not NAND gate. So now, in case of clocked RS, there is third input, clock, R, S, Q, and Q bar. Okay, if the clock is 0, whatever may be the state of your R and S input, whatever may be the states of your R and S input, Q and Q bar will remain in the last state. So if Q is 1, Q bar will be 0. If Q is 0, Q bar will be in the 1 state. So this is the condition when your clock is 0. Now, if the clock is 1, for example, if the clock is 1, and if both the inputs are 0, if clock is 1 means this side is 1, this side is 1. And if both the inputs are 0, now what will happen? The outputs will be 0 again. Outputs of the AND gates will be 0. So again, it will remain in the last. Okay. So we are getting the last states for two different conditions. One is when the clock is 0, the flip-flop will enter into the last state, or it will be in the last state. Or if clock is 1 and R and S are 0, then also your flip-flop is remaining in the last. So this is controversy to what we have studied in the simple RS flip. Okay, in case of simple RS flip-flop, using NOR gates, whenever the inputs are 0, 0, R and S inputs, then it will be entering the last state. But here, in clocked RS flip-flop, even if the clock is 0, then also the flip-flop will remain in the last. That is the difference. Or you can say addition. One more last state addition has been done due to the clock. Now, if the clock is 1 and if your R is 0 and S is 1, okay, as we know, Q will become 1 and Q bar will become 1. When the clock is 1 and if R is 1 and S is 0, Q will become 0 and Q bar will become 1. And if clock is 1 and both the inputs are 1, then it will be in the 0, 0, that is invalid. is the invalid. So invalid state will be only one. If the clock is one and both the inputs R and S inputs are one, the outputs will become Q will also become 0 and Q bar will also become 0. In that case, we call it as this is a controversy to what we say as Q and Q bar. If Q is 1, Q bar must be 0. If Q is 0, Q bar must be 1. But here both the outputs are becoming 0. So this is an invalid step. Okay. So this is the working of the clocked RSP. As far as the symbols are concerned, symbol of simple RSP, clocked RSP clock. I will draw it. Yes. R clock. This is clocked RS. This is the symbol for clocked RSP. Okay. Now, it is not important that whether you are using RS flip-flop using NOR gates or RS flip-flop using NAND gates. Either of the universal gates you can use for making a RS flip-flop. Either you can go for NOR gates or you can go for NAND gates. That doesn't matter much. So I think it is clear. Now, I want to add what I will do. Now I will add one more gate here. I will add, say, NOR gate. Dot the two inputs. Sorry. Write in inverse manner. I call this as D input. And this is the clocking. So the truth table will change now. Clock D, Q, and Q bar. If clock is 0, then whatever may be your D input, 1 or 0, the outputs of the flip-flop will be in the last. Whenever the clock is 1, and if D is 1, then only Q will be 1, and Q bar will be 0. If clock is 1, and if D is 0, Q will be 0, and Q bar will be. Okay. So what is the difference between the simple D flip-flop and clocked D flip-flop? In case of simple D flip-flop, there was no last state. Okay, there was no last state. But in case of clocked D flip-flop, we get the third state, that is called as the last state. So the last state which was absent in the simple D flip-flop, it has now emerged in the clocked D flip-flop. That is the basic difference between the simple D flip-flop and the clocked D flip-flop. That you have to remember. So again, we will revise what we have learned. First is simple RS flip-flop. using NOR gates. Second, simple RS flip-flop. Using NAND gates. Third, simple D flip-flop. Using RS flip-flops. Fourth one, blocked RS flip-flop. And fifth one, blocked D flip-flop. Okay, all these things we have studied. What is the symbol for clocked D flip-flop? That is also very simple. We have two inputs. One is D input and second input is clock in. And we have two outputs, that is Q and Q bar. So this is clocked D. In this way, we have summarized what we have learned in the flip-flops. Okay. Now, in the next class, I will discuss the what advantages and disadvantages you see. In case of D flip-flop, there is only one input. That is the drawback of the D flip-flop. But it, what improvement it makes? D flip-flop, it removes the condition of invalid state. Okay, in case of D flip-flop, we don't have any invalid state. That is the advantage of the D flip-flop. What is the advantage of RS flip-flop? In case of RS flip-flop, we can use two inputs, control inputs. But what is the problem with RS flip-flop? The problem with RS flip-flop is that there is an invalid state. Okay, whether it is a simple RS flip-flop or clocked RS flip-flop, the problem is invalid state. Okay, so this problem of invalid state. Okay, so RS flip-flop has one advantage and one disadvantage. What is the advantage of RS flip-flop? It has two control inputs, R and S. But what is the disadvantage? It has invalid state. What is the advantage of D flip-flop? It doesn't have any invalid state. But what is the disadvantage? It has only one input. Control input is only one. So each flip-flop here, whether it is RS flip-flop or D flip-flop, both are suffering from one drawback and one advantage. Okay. Now, how to overcome the drawback of RS flip-flop and the drawback of D flip-flop? And that's why we come to the next flip-flop that is called as the JK flip. JK flip. JK flip-flop is the improvement over RS and D flip-flop, which removes the drawbacks of RS flip-flop as well as D flip-flop. That is the advantage of the JK flip-flop. So in the next conversation, I will just discuss about the JK flip. Thank you so much. I will end my meeting here.